This is problem 2 on exam 1 of module 7 in the book Problem Solving Guide for Electromagnetism and Optics. The study of elementary particles, strong magnetic fields, along with conservation of energy, momentum, and charge are used to determine the weight, speed, and charge of new particles that are sucked out of the vacuum, particles that have been extinct since the Big Bang, shortly after the strange quark was discovered in the lambda zero particle. Lambda zero is up, down, strange. It was a new quark. Protons and neutrons are composed of up and down quarks. The strange quark was new, which is why they call it a strange quark. And as soon as you find the strange quark, you say there must be a triple strange particle. And they called it the omega minus, and there was a big race to see who would discover the omega minus. Which way would the omega minus curve if it was shot into a magnetic field as shown in the diagram? Omega minus is negative, the velocity is to the right, so we put our thumb to the right and our fingers pointing out of the page. Our palm is facing downward. This is the direction of V cross B. The omega minus is negative, which means the magnetic force is upwards, so it's going to curve upwards, and of course, since the direction of the velocity is changing, the direction of the force is going to change. Initially, it's upward, but it's always perpendicular to the velocity, and thus a central force. That's part A. Part B, the mass of the omega minus is 2.98 times 10 to the minus 27th kilograms. What magnetic field is necessary to curve it in an arc of a radius 10 centimeters if it is traveling at 10,000 meters per second? The magnitude of the magnetic force is QVB, and it's the only force on the particle when it's in this magnetic field region. There might have been some crossed E and B fields in the velocity selector, but once it's in the field region, the magnetic field force is the only one on the particle. So QVB is MA, and A is V squared over R because it's moving in a circle. And we can solve for B by substituting in the knowns. B is mv over qr. The mass is given. Speed is given. It's a singly ionized particle. That's the charge. And the radius converting to meters, 0.1 meters. So the answer is 1.86 millitesla. That's problem 2.